First, let's start with create the part, the pipe part. Ready, deformable solid extrusion. Continue, and let's create two circles. The first one with radius equal to 100, and the second one is with radius equal to 49. The first one is 100 in the diameter. That means we have 15 in the radius, and also the second one 49 in the radius. Click done. When the length of our pipe is equal to 2 millimeter. As you can see here, we have our pipe structure when we need to create the crack. Now we will create the second part that represents the crack and the circle in the front of the crack to create interaction, to create combine and merge between two parts to create pipe with crack. Let's go to the second part, add a name. For example, crack structure with 3D deformable shell extrusion. Click continue, and now we will create two, the main structure of our crack and the front of the crack. The first one is the crack line. For example, in our case, we will use 20 millimeter in the length of the crack, and also we will create two circles in the limits of our crack, and also create addition lines. These lines needs in the partitions for simplify the mesh in the geometry of our pipe. Click done and add the length equal to, for example, 10 millimeter. As you can see here, we have crack and two circles in the front of the crack. This structure needed for creating the partition in the pipe. Let's go to the assembly and select two instances. Now we have this part and this part. Let's go to again to the part and select pipe. And create two datums plan to create interaction, to create partition in the pipe. The first one is CNC plan with offset equals 0, and the second one the Y and Z plan. And let's go to create partition of the cell using datum plan. Select datum plan, create partition, and select two cells. Okay, select datum plan, create partition. Now we have two partitions in our pipe. Let's go again to assembly, and we need to move this part in the right position in our position of the crack. First, we need to rotate this part in the right position. Let's select the axis of rotation Okay, and the second rotation in the z-axis around the axis. Okay, now let's move this part to the position of the crack. For example, in this position, click OK. Now translate this part upper in the y direction with 5 millimeter. Now let's go to merge, cut geometry. Let's add a name, for example, pipe with crack. Press, continue, select the instance to be cut, the pipe, click on, and select the instance that will make the cut. We will make the cut by this instance. Click OK. Now, as you can see here, we have the pipe with the partition of the crack and the front of the crack. Let's go to the part and pipe with crack. As you can see here, we have our pipe with crack partitions. Now, let's go to create property, and we will use elastic behavior for steel material. Elastic with Young geometry is equal to 210,000 megapascal and potential ratio 0.3. Okay. Now let's go to create section, steel section. Continue, select the steel material. Okay, and select and assign the section to our part. Click done, and now we have assigned the material, the section with steel material to our part. Let's go to assembly, and in assembly we should convert the instance to independent part. Let's go to the step and create static analysis step and change the initial increment to 0.01 in our case. Now let's go to file output, edit, and in this case we need to get the J integral value. You can select GK, line spring, G integral stress and toxicity factor. Select this value to get in the output database. Click OK. And now let's go to the main step in our model is the creating the crack in the pipe. First, let's go to special crack assign seam, and we need to select the position of the crack. We need to select these faces where we need to create the crack. This value equal to 220 millimeter. This is the position of the crack, and click OK. This value, this selection means we have no material, no continuity of material in this section. We have, as you can see here, as showing, we have no material in this position. Click done. Now let's go to create crack. We have two cracks. The first one in this position, the first front of the crack, the first contour, and now select normal to Q plane, select vector of direction of the crack, and click. You can select OK, and or you can select more options in the singularity by changing the value of mid-side node parameter 0.25 and collapse element side by single or duplicate node. Click OK. And we have the first crack. Let's go to the second crack. We have crack 1. Let's create another one. Crack 2. Select the front of the crack. Click on. Select the vector of direction of the crack. And also change the singularity. Okay. Now we have two cracks in our pipe. Let's go to the load and apply the load to our and boundary condition to our pipe. First is the encaster in the two limits of the pipe in the initial step. Click on encaster. Okay. Depending to your boundary condition, you can change this boundary condition and select second limits of the pipe. Click on and encaster again. And now let's apply pressure in the inner face of the pipe. In the step 1, apply select pressure, continue, and in this position select by angle to select the wall surface in one step. Click on and apply the pressure in the pipe. Our unit in the pressure is in the Newton per millimeter cube. You can change the value depending to your load. And now let's go to the next step is the mesh step. In this step, we will make necessary steps for make the mesh more adequate to our part. The first step is change the element type using mesh control, using hex dominated with the sweep technique, medial axis, click OK. Now let's go to mesh edges in the front of our crack by using the seed edges. Select edges in the front. Click on and select by number. Let's use 5 elements in these edges. And also you can change these size in these edges. Click on and also you can use by number, apply 5. Okay. And in these edges you can change the mesh using, let's use advanced front. Click OK. Let's go to mesh the wall part. Click yes. In this side, let's go to these cells and change the mesh using medial axis. Click OK. Delete previous mesh. Mesh again. Click yes. We have problem in these edges, this zone. Let's use triangular element. Okay, mesh. We have problem. Let's go to delete seeds element. Yes, and mesh again. Let's go to change the type. Let's use X dominate, sweep, medial axis. Okay, mesh again. Now we have the right mesh in front of the track. We have triangular elements. Depending to your problem, you can make your mesh more finer, but in our case we will use for testing. Let's go in this part, in this step. Let's go to the mesh, to the step, and in the file output, in the history output, let's go to edit, select web model, select crack, the crack one, and select G-integral in 5 contours. You need to add and set the number of contours to get the value of G-integral. Click OK, and add another one. Select crack, crack 2, G-integral, and also 5 contours. Click OK, and now let's go to the job and create job. We have completed job. Let's go to the result, and you can see the deformed shape. You can see the opening of the crack in our pipe. If you have a wrong shape in the crack, you can set the size of, you can use deformity scale factor and set to 1 or 10 to see the crack and the deformed shape. For example, if you use 1000, you can see this wrong deformed shape. Let's go to use 1. For this, the real value, you can see the, the crack in this part, but you can add more scale to see the crack clearly in your deformed shape. Let's go to the stresses analysis. Let's see the crack. Now you can take a look at the von Mises stresses in your front of the crack. Let's go to the history output. You can select the integral in fronts, in any fronts, in the crack 1, in the crack 2. For example, this one. And you can go to file output. Integral. We can see the value of J integral in the file output, ODB file output. Let's go again to, we can't get any real data. Let's go to deformed shape, and let's go to the job, go to monitor, data file. You can see the J integral in the contours, 1, 2, 3, 4, 5 contours in the crack one. As you can see in the crack one, the value, and also in the crack 2, you can also see the value of the integral in each contour. Until now, I hope you enjoyed with this video. Don't forget to subscribe in my YouTube channel and like this video. See you.